everyone, we're from Team Dark.NotLight. Today we're going to share the result that we achieved for black box attack in autonomous vehicle. Now let's have a view on why we choose this topic. Imagine you're driving on the road with your Tesla, and your car suddenly determines that a mailbox is not just a mailbox, but a person crossing the street. It might sound hilarious, but it's a real concern in the area of autonomous vehicle. So why we choose black box attack? The real-world environment in which autonomous vehicles operate is highly dynamic and unpredictable. Autonomous vehicles must adapt to various road conditions, weather, traffic, and unexpected events. While white box attack typically assume to have the access to the model may be not realistic for autonomous vehicle technology because of many dynamic elements primarily related to sensor data. Next, using black box attacks in the context of physical adversarial traffic sign is a relevant and concerning issue, as physical adversarial traffic sign could be generated by adding stickers or paint. First, we'll look at the data preparation. We import the required library, load and preprocess the text images, and classify them, and look into how we transform the tensor object to image data, and finally display the result. The model being used for the attack is a pre-trained ResNet-18 architecture from PyTorch. ResNet-18 is a deep convolutional neural network that has been trained on a large dataset, including the ImageNet dataset, to perform image classification tasks. This specific ResNet-18 model is loaded with pre-trained weights, which means it has already learned to recognize a wide range of objects and concepts from images. Next, this is the load and preprocess function, where we pass in the URL of the images, and it will then convert that image to a tensor and normalize the pixel value based on the predefined mean and standard deviation. While this classify function passes the processed image through the pre-trained ResNet-18 model, obtaining prediction in the form of a label and a confidence value. In this tensor to image function, transform back the tensor object to the image data. Finally, we use this visualize function to display our result. After data preprocessing, we are then going to look into the attack methods. These are the methods that we are used to attack the model, which are semantic attack, noise attack, combined attack, symbol black box attack, and the modified version. First, semantic attack is an attack that can manipulate visual information in traffic sign image to deceive computer vision system. Basically, it takes the input image X and negates it by multiplying it by -1, as we can see from here, creating a negative or opposite version of the input image, which is shown in this diagram. This is the result of the semantic attack. We can see that although this attack failed to trick the model, however, it did reduce the probability of identifying it as a threat sign from 14.48% to 10.40%. And the success rate of using semantic attack on 250 test images is 89.6%. Moving on will be noise attack. This attack manipulates the image by introducing unwanted visual distortion or artifacts, commonly referred to noise. The magnitude of the noise is controlled by the epsilon parameter, or in our case we use 0.7. And the generated noise is then multiplied with the epsilon, and then is added to the input image X by performing element-wise addition, resulting in a perturbed image. By observing the image, we can see that the grainy inside this picture is the noise. This attack successfully tricked the model as it predicted it as a chain link fence. And the success rate of using this attack on 250 test images is 96.8%, which is higher than the semantic attack. Next, Zing will talk about the other attack.
Hi, I'm Zing. I'll be continuing to explain on our attacks. The combined attack is a combination of semantic attack and noise attack, which is a more complex attack compared to the previous attack. The semantic component alters the traffic sign's visual appearance, such as its color or shape, to confuse the recognition system's semantic understanding of the sign intended meaning. Simultaneously, the noise component introduced random variation in the image data, mimicking real-world environmental noise or sensor imperfections. And here's the result of the attacks. Next, for the simple black box attack, SIMBA, that we created ourselves, it is a targeted adversarial attack that exploits vulnerabilities in machine learning models responsible for traffic sign recognition. It will add random perturbation to the image at every iteration, and it will stop iterate when the classifier has been full or it reaches the maximum iteration number. And this is the result of SIMBA attack. Lastly, the modified symbol black box attacks, MSIMBA, which we reference from our research paper, and it is an adversary seek to deceive the model without direct access to its internal parameters or gradient, making it a black box attack. This attack focuses on minimizing the loss of the class where the model exhibits the highest confusion. It iteratively perturbs input image, considering positive and negative gradient updates to consistently mislead the model in classifying traffic signs. And this is the result for MSIMBA attack. Now we are going to analyze the result of these 5 attacks on 250 test images. Our semantic attack achieved a success rate of approximately 89.6%. Next, the noise attack proved quite effective with a success rate around 96.8%. The combination of both semantic and noise attacks increased the success rate to nearly 98.4%. SIMBA, our black box attacks, exhibit remarkable success with a perfect 100% rate. Lastly, our modified SIMBA, MSIMBA, achieved a commendable success rate, approximately 98%. So from the result of these 5 attacks, we can observe that more complex attacks have higher success rate. In conclusion, this result suggests that traffic sign recognition systems used in autonomous vehicles and intelligent transportation systems are susceptible to adversarial attacks. While individual attacks like semantic and noise attack can be effective, a combination of these methods and more advanced black box attacks like SIMBA and MSIMBA can further increase the success rate of deceiving the models. This highlights the need for improved robustness and security measures in the development of autonomous vehicle technologies to mitigate the risk of false detections and ensure the road safety. So this is the end for our presentation. Thank you.